Today, we're going to talk about two absolute masters of speed. One was forged over millions of years of evolution, and the other, born from the absolute peak of human engineering. Now, you might think they're worlds apart, but as you're about to see, they are so deeply connected in a way that reveals an incredible secret about where the best ideas really come from.
All right, first up, our hero from the natural world, the peregrine falcon. Look, this is not just some bird. It's a living, breathing testament to what evolution can do. This creature has so completely mastered the physics of flight that it's basically the final word on natural velocity.
And its counterpart from the world of steel, wiring, and raw power, the Suzuki Hayabusa. And again, this isn't just a motorcycle. It's a machine built for one single audacious reason: total, absolute domination on the road with unmatched, frankly brutal performance.
So a bird and a bike. What on earth could be the hidden link between them? Well, answering that question uncovers this fantastic story about design, about inspiration, and about the incredible secrets that are just hiding all around us in the natural world. Okay, so let's start with the bird, the peregrine falcon. And when I say it's fast, I mean it's basically a living missile.
To really put this into perspective for you, when this falcon tucks in for its hunting dive, it can blast past 320 kilometers per hour. That is faster than the takeoff speed of most commercial jets. It is, no exaggeration, the fastest animal on the entire planet. But what's really fascinating is the problem this creates for scientists. I mean, how do you even begin to study an animal that moves that fast? It maintains this incredible agility, and it pulls out of these dives with crushing G-forces. It's just so unpredictable out in the wild that getting any precise measurements is next to impossible.
Now, let's switch gears. We're going to leave the natural world for a second and jump to the mechanical. Because back in 1999, the entire engineering world was about to get completely turned on its head.
And this is why. The Suzuki Hayabusa. When this thing was released, it wasn't just another bike hitting the showroom floor. No, it was a statement. It was a machine that fundamentally redefined what anyone thought was possible for a bike you could actually go out and buy.
The impact wasn't subtle, it was immediate, and it was absolute. It didn't just go out and break a few records. It literally created an entirely new category of motorcycle, the ultimate sport bike. And for more than 2 decades, the Hayabusa has been the yardstick for raw, untamed performance. So we have these two champions of speed, right? But what about that hidden link I mentioned? Well, it's been hiding in plain sight this whole time. The key to the whole story is in the name.
Hayabusa. It's the Japanese word for, you guessed it, peregrine falcon. This was no accident. It was a deliberate, really profound tribute. You see, Suzuki's engineers weren't just inspired by the Falcon's speed. They were obsessed with its total mastery of aerodynamics, the very same challenge they had to conquer to build the world's fastest bike.
So this is the crucial question, right? Why the Falcon? What aerodynamic secrets is it hiding that world-class engineers would want to copy? Well, to figure that out, scientists had to get really creative. So how do you study a living missile? Well, with a pretty brilliant method. First, the researchers actually trained falcons to dive down the face of a 60-meter dam wall. This gave them a controlled backdrop to film against. Then, they used high-speed cameras to map out the entire 3D flight path. And from that data, they built a perfect 1-to-1 scale model of the Falcon, which they could finally take into a wind tunnel for testing. And in that wind tunnel, the model immediately showed a classic high-speed problem called flow separation. Basically, these are little pockets of turbulent, chaotic air that form over the body. You know, at low speeds, not a huge deal. But at the speeds we're talking about, they can cause a total, catastrophic loss of control. So this was the million-dollar question. The model was showing all this instability, but the real Falcon is a master of precision at these insane speeds. So what was the model missing? What was the secret?
And the answer is just, it's beautiful. When the scientists went back and compared the wind tunnel data to super high-res photos of the actual diving Falcon, they saw it. In the exact same spots where the model predicted dangerous turbulence, the real bird's feathers would just slightly pop up.
This amazing trick is a biological mechanism called passive flow control. Those feathers are basically acting like tiny automatic spoilers. The bird doesn't even have to think about it. The airflow itself makes them rise just enough to smooth everything out and keep the Falcon perfectly stable. It's just this elegant, self-correcting system.
So, nature has this elegant, automatic system. Now let's see how human engineering solved the very same problem.
The designers of the Hayabusa faced the exact same puzzle. How do you manage airflow and stay stable when you're pushing the absolute limits of performance? The entire shape of the bike, that iconic wind-slicing silhouette, is the result of thousands of hours of obsessive work in a wind tunnel. The whole point was to get one of the lowest drag coefficients of any motorcycle ever, while making sure the bike and the rider didn't get tossed around.
And this right here perfectly shows the two different approaches to the same goal. The Falcon uses passive control. Its physical design just reacts automatically. The Hayabusa, on the other hand, uses active control, a complex suite of electronics that is constantly thinking and making adjustments.
And that electronic brain is the Suzuki Intelligent Ride System, or SIRS. It's this incredible web of sensors all working together. You've got traction control to stop the rear wheel from spinning out, anti-lift to keep the front wheel on the ground when you accelerate hard. All of these systems are watching everything and making changes in milliseconds. And it's all designed to do the exact same job as the Falcon's feathers, give you rock-solid stability at ridiculous speeds.
So what we have are two incredible solutions to high-speed stability. One is natural, one is man-made. And what's really cool is that both have continued to evolve over time. I mean, just look at the numbers. You can see the constant, relentless push for perfection from Suzuki's engineers. That 0 to 100 time just keeps getting faster and faster, a true testament to their skill. But then you look at that top speed. Even though the Hayabusa is electronically limited, the Falcon, with its design perfected over millions of years, still holds the ultimate speed crown. It seems nature is still the reigning champion.
What you're looking at here are 3 generations of engineering genius, each one a masterpiece for its time. But in a way, they're all chasing a blueprint for performance that was perfected by natural selection long before we ever even dreamed up a wind tunnel.
It really makes you wonder, doesn't it? As we keep pushing the boundaries of our own technology, how many more answers to our greatest engineering challenges are already out there, flying, swimming, and running around in the wild, just waiting for us to stop and look close enough to see them?